All right, so I just want to talk about what linear programming is. So we have been doing inequalities, and we can see that inequalities cross over, and you have this region where they cross over. Linear program is as it says, a technique to identify the maximum and minimum value of a certain quantity. All right. This is like a modeling, so this is going to be used in word problems. I mean, linear programming is really used in real world examples. You have an objective function. The objective function is what you are trying to find the min and max of. So objective function is kind of your end goal. If your objective is to find the maximum profit, then they will give you a profit equation, and that is your objective function. Then you will have what's called constraints. Constraints are exactly what they sound like. They constrain on what you can and can't do. For example, if you have a bakery, you are constrained by what you have available: flour, eggs, milk, etc. All right? And so you will find your objective function. What am I trying to do? Maximize profit. Well, what are my constraints on that? And you will have those. And so the objective function just kind of gets put off to the side at first. You kind of leave that one alone, and you look at your constraints. You graph all of your constraints. And what your constraints do is they create what's called a feasible region, which is what they're showing here. Your feasible region is all of the numbers that fit inside of your constraints. And so then you're going to take all those numbers and say, which of these numbers will give me the maximum or the minimum or whatever my objective is for my objective function. And so then you go back to your objective function, all right? And so they've given us the example here. Which I don't actually think they... Vertex Principle of linear programming. So when you do your constraints, you're going to get this feasible region, whatever it is. And somewhere in that region is your maximum profit, per se, if that's what your objective is. Well, you don't want to test every single point in that. That would take you forever. First of all, there's technically an infinite number of points. And second of all, right, we have to know where to start. This principle tells you that your maximum or minimum value is always going to be on one of your vertices, okay? So that means if you have a rectangle, you are going to test 4 points because the vertex is going to give you the max or min. One of the vertices will. And so you test just the vertex. Each vertex you're going to test back into your objective function. And one of them is going to give you the biggest number. One of them is going to give you the smallest number. The biggest number is the maximum. The smallest is the minimum, okay? And so that's what linear program consists of. We're going to do an example today just of here's your objective function, here are your constraints. What we're going to move to is you're going to have a word problem, and they're going to say, hey, they want to maximize their profit, and they make this much from here, this much from there, and you're going to create all of these equations, okay? So in a word problem, they don't hand you the equations, you create them. Here, they're handing the equations so that we can just see visually what it looks like, all right? So let's look at this example, example 1 here. It says, find the values of x and y that maximize and minimize p for the objective function p equals 3x plus 2y. So they right there hand us our objective function. He's right there. We do not graph our objective function. He just sits there until the very end, okay? Objective function is what you're trying to maximize or minimize. So find what that is and just set him aside, all right? Then they have given us our constraints. And so we have a constraint of this guy right here. This is a very common constraint in a word problem. You'll notice that I only have the first quadrant up here because one of the constraints is that y is larger than 0, greater than equal to 0, and that x is greater than equal to 0. That just threw me into my first quadrant, okay? Most word problems will have this because if you have a constraint of like this amount of flour and this amount of eggs, you're not going to have a negative amount of flour and a negative amount of eggs, right? And so many of your word problems will also be constrained by the first quadrant. So that's easy. My first quadrant, I actually don't need to graph that guy. I can just worry about staying in the first quadrant. The other two are constraints. So I'm going to graph them. And so I am going to graph this first one here. Y equals 3/2 x minus 3. I'm going to graph it just like we did in those. Now, I will say for this one, because I'm in only the first quadrant, my y-intercept is down below, all right? And so if that happens, you can actually do your intercepts if you want to. So you can graph by intercepts, which is how most of these are going to happen. And so I'm going to show you how to graph this by your intercepts. We have this right here. All right. My x-intercept. Where is my x-intercept? How do I find my x-intercept? What would I do to find my x-intercept? Yeah, I want y equal to 0. So yes, I'm gonna y equals 0 is gonna be my x-intercept. All right, add my 3 over. What do I do here? Keep, change, flip, right? So what is my x-intercept? And actually we can just do equals here. How do I keep, change, flip? 3 times 2/3, right? Which is just 2. My x-intercept is 2 here, okay? So what you can we're used to graphing by y-intercept. We can graph by x-intercept. It is a point on the line, all right? What is my slope for this line? What's my slope? 3/2. So from any point on the line, I can go up 3 over 2, right? Up 3 over 2. All right, so we're used to graphing by y-intercept, but if you're constrained by the first quadrant, you don't have to do that, all right? You can use it the other way. And you can see that if I went down 3 and over 2, I would be at -3. Like you can see that, right? All right, so then I'm going to graph this line. Is it solid or is it dashed? Solid, all right? And then, am I graphing above the line or below the line? I'm graphing above the line, all right? So I'm going to shade above the line there. So I'm going to shade above it. And I'm staying in my first quadrant because of the last constraint. All right, let's look at the next one. He is already in slope-intercept. Already in slope-intercept. So where do I start for this one?
7.
And how do I move? Down 1 over 1. So I'm going to go down like this. And you can actually walk to see where they're going to intersect. They're going to intersect right there if you want to walk it, right? So that you don't have to worry about, you know, messing up your graphing there.
Are all these going to intersect at some point?
Solid line here, right? Above or below? All right, so below is going to be here, all right? And then you can see that a wedge is created, right? So my answer, my feasible region, so in these you're looking for a feasible region. Your feasible region is going to be this right here. All right? I am going to now figure out where are my vertices. So I have a vertex right here, right? Everybody see that? 0, 0 is a vertex. I have a vertex right here. So I have a vertex at 0, 0. I have a vertex at 2, 0. I have a vertex right here. Where's this? 4, 3. I have a vertex right here. 0, 7. Okay? So I have 4. Now I'm going to go back to my objective function, all right? So now I'm going to go back up here to this objective function. Now I'm going to use this, all right? Now, how do I use it? Well, I am going to take those 4 and I'm going to plug it into my objective function, all right? So I'm going to take those 4 vertices and I'm going to plug them into my objective function. My objective function was P equals 3x plus 2y, all right? So I'm going to do it at 0, 0. Well, that's going to be 3 times 0 plus 2 times 0. I'm going to do it at 2, 0. 3 times 2 plus 2 times 0. Everybody see what we're doing here? I'm going to do it at 4, 3. 3 times 4 plus 2 times 3. Right? And then I'm going to do it at 0, 7. 3 times 0 plus 2 times 7. All right? They want to know where the maximum occurs and where the minimum occurs, all right? Where the maximum occurs and where the minimum occurs. And so your answer is going to tell me that. You're going to say, well, a minimum, the minimum is 0, I'll just say min, is 0, and it is at the point 0, 0. My max, what is my max? My max is 18, and where does it happen? At 4, 3. So this whole thing here would be my answer. Just some guided notes about linear programming. Linear program is a method for finding the maximum or the minimum value of some quantity given a set of constraints. So your whole goal in linear programming is to find maximum and minimum. Sometimes they will say, where does this occur? Or what is the maximum or minimum? So you have to understand what they're asking. If they're asking what the maximum or minimum is, then you are going to tell them the value that happens when you plug it back into your objective function. If they ask for when it occurs, you're going to give the x and y value where it happens. And it just depends on what the problem is asking for. Constraints are the inequalities limiting the problem at hand. So if they just hand you a problem, then a constraint is just going to be some type of inequality function, right? They're going to have x is greater or equal to 0, x plus y is greater than 7, whatever, constraints. If it's a word problem, it's actually going to be limitations on what you have the ability to do. If it's working, well, they can only make so many automobiles per hour because that's the ability they have to do it as far as the factory goes. And so limitations happen in word problems. They happen when they just hand it to you. The feasible region is the shaded polygonal area created by the intersection of the graphs of the inequalities. So the feasible region is that intersecting graph that happens when you graph your constraints. That is the feasible region. It's the location where every constraint is met or satisfied. So you're going to have a section of your graph that every point in there meets all of your constraints. An objective function is a function in two variables, f of x, y. That is the objective to maximize or minimize, such as profit, minimize cost, whatever. If a function has no maximum value, the shaded region of the constraints are unbounded since they do not form a closed figure. So there are going to be times when you're handed constraints and it's unbounded one direction, which means it goes on infinitely off of that graph. You're not going to have a maximum, but you would have a minimum in that case. And so you could have an unbounded region even with some of these word problems. Sketching a feasible region. Graph each inequality on the coordinate axis system. Find the feasible region by shading. Determine the vertices of the feasible region. Evaluate each coordinate in the objective quantity. Determine the maximum, the highest value, the minimum, the lowest value by substituting those in. So these are your steps to solving your linear programming problems. Sketch the feasible region. So we're just gonna graph these. So the first one is x is greater than or equal to 3. What type of line is x is greater than or equal to 3? It's a vertical line at 3. So we're going to go to 3, and we're going to draw a solid or dashed vertical line. A solid vertical line here. Solid vertical line here. All right? Greater than or equal to. Which side of that am I going to shade on? Right or left? The right. Greater than or equal to. X gets bigger on this side of the graph, right? The next one, this is y is greater than or equal to 2. What type of line is this? This is a horizontal line, all right? At 2. So we're going to go to 2 on this graph. And we are going to draw a solid horizontal line. Okay, if we can get to there. There we go. Solid horizontal line here. And am I going to shade above or below it? Above it. All right. So I'm going to shade above this one. All right. Y is less than or equal to 7. Once again, this is going to be what type of line? There's going to be a horizontal line, right? At 7. solid line above or below for less than or equal to 7. Yeah, we're going to shade below it. So that's going to be this guy right here. And then x plus y is less than or equal to 10. Now, when you have one like this, you don't necessarily have to put it in slope-intercept form. You can just use your x and your y intercepts. So if I'm finding my x and y intercepts, remember, to find my x-intercept, I just make y 0. So my x-intercept is going to be 10. And to find my y-intercept, I just make x 0. So my y-intercept is also 10. So I can go to 10 on the y-axis and 10 on the x-axis, and I can just graph those 2 points. So when word problems especially, intercepts will likely be the easiest way to do those. So there's my line there. And this is above or below it. So what's the region that's going to be created here? Where they all overlap? Yeah, it's going to be this triangle right here. This triangle right here is where they all overlap. All right. If you want to wait and shade at the end, you can. All right. So if I wanted to, I could wait and say, okay, below this, above that, to the right of this, and there. I just find that sometimes when you do that, when you try to just look at it and figure out what it is, you sometimes do it wrong. So you may want to just lightly shade with your pencil so that you can get an idea of where it is. And then when you figure out what your region is, then you can shade it darker and you know, okay, this definitely is my region. And so once you figure out your region, you've got it. Now, so my first step is done. Find the feasible region by shading everything correctly. And so I have this feasible region here. And I know that I have this triangle. All right, so my next step is I need to know what my vertices are. I'm just trying to clean this up a little so y'all can see it better. My vertices, this is where my max and min are going to occur. They're going to occur at my vertices. All right, so I have to find out what my vertices are. And this one was an easy one. They gave me ones that cross nicely. I have a vertex right here. Okay, what point is that?
3, 2.
That is 3, 2. So I'm going to test 3, 2. All right, I have a point right here. What's this guy? 8, 2, right? I have a vertex right here. 3, 7. All right. Since it's a triangle, how many vertices should I have? 3, okay? All right, so now that I have that, so I have graphed it, I have found my feasible region, I have found my vertices, I'm going to evaluate them into my objective function, all right? So my objective function here, we'll just create an objective function for this one so that we have something to test it in, all right? Objective function, find the maximum and minimum value here. So if this was my objective function, I would take those x and y's and plug them in. So 3 and 2. 3 times 3 is 9, plus 2 times 2 is 4. 9 plus 4, that's going to give me 13. All right. When I plug in 8 and 2, what do I get there? 24 plus 4. And then what about 3 and 7? 9 and 14, hopefully, right? So my minimum is going to be, minimum is 13, and it happens at the point 32. My maximum is 28, and it happens at the point 82. All right. So your intercepts here, my x-intercept is going to be just 9. My y-intercept is going to be 9/2. So 4.5 there and 9 down here. So this is 4.5 on my y-axis. This is 9 on my x-axis. I have 2 points. For this one, I used my x-intercept. So my x-intercept here, my x-intercept is just 3. And then if you put it in slope-intercept form, you get y is greater than or equal to x minus 3. Negative 3 is off my graph, so I just used my x-intercept 3. So that's right here, and my slope of up 1 over 1. It doesn't matter what point on the line you start with, as long as you start with a point on the line and use your slope, you can graph the line. And then you have to look at where your shading is. My shading is going to be above this green line, to the right of the blue line. It's going to be below the purple line. And it's also going to be above this line here. Above this line. So it's going to be this shaded region right there. So my shading for this is going to be right here. That is the region that I have. And then I'm going to test my vertices. All right, for vertices, I have 0, 1. I have 4, 1. I have 0, 4.5. And I have 5, 2. And I'm going to plug those in. So 3 times 0 plus 1 is going to give me 1. 3 times 4 plus 1 is going to give me 13. 3 times 0 plus 4.5 is going to give me 4.5. And 3 times 5 plus 2 is going to give me 17. Specifically, they were asking maximize, so make sure you answer your question. What maximized this? Well, this is your maximum. So your maximum, my max is 17, and it happens at 5, 2. This says, suppose you're selling cases of mixed nuts and roasted peanuts. You can order no more than a total of 500 cans and packages and spend no more than $600. How can you maximize your profit? How much is maximum profit? All right, so let's look at this. It says, when you're reading these problems, your goal is to figure out what their objective is. So your objective is to figure out their objective, okay? If you look at the last line here, it says, how can you maximize your profit? How much is the maximum profit? So what they're saying is, we want the value of the maximum and the at point where you get it. With this, they're saying, how many of each do you need to sell to reach your maximum profit? So our profit equation is going to be based off of how much they sell these for. Okay, how much they sell these for. So if you look at your how much they sell each for, you'll say, on top of this, they actually tell you profit. They don't just tell you how much they sell it for. So the first thing that you want to do here is figure out what your objective is. So my objective is to make a profit. I need to assign variables. It's important that you tell me what your variables are, and it's important that you tell yourself what your variables are, okay? Because if not, at the end, you're going to have all these graphs, and you're going to be like, hey, which one was mixed nuts and which was roasted peanuts, right? And so you want to make sure that you're like, okay, X, that's going to be mixed, and Y, that's going to be peanuts. And no, it does not matter which one you choose. Honestly, what's going to happen is if you choose opposite variables, it's just going to flip-flop your graph, and your profit and max are still going to be the same. You're just going to have X number of roasted peanuts and Y number of mixed nuts. It's going to be the same profit, and you're going to have the same answer when you get to the end of it. All right, so if I set it up that way, then what's my profit for my mixed nuts? $18 times X. That would be how much profit I make with that. If I add to it my profit for my roasted peanuts, what am I going to add? 15Y. So this right here is my profit equation that I'm trying to maximize. Okay? Done. Then we have to look at constraints. All right? There are constraints written in this. The first constraint says you order no more than a total of 500 cans and packages. So you order no more than 500 cans and packages, which means that if I add all of my cans of mixed nuts and all of my packages of roasted peanuts, it's going to be no more than 500. So how do I represent that in variable form?
Y is greater than or less than or equal to 500.
Not just Y.
X plus Y.
X plus Y, all of it together, okay? All of it together. So we're going to say X plus Y, no more than, less than or greater than? Less than or equal to, right? And that's going to be 500. The next constraint that they give me has to do with my cost, right? So it says spend no more than $600. So the cost of my mixed nuts and the cost of my roasted peanuts can be no more than 600. How do I represent that algebraically? Cost.
Is that where you start? 'Cause that's
Yep, 24x is what? Less than or equal to 600. And I actually didn't realize they did this, so we're going to have to throw something into our other equation. They actually don't want, not the whole group, they actually don't want any more cans or packages. So we're going to have to add something to our X plus Y. What do we need to add there? Yeah, we need to add the 12 and the 20. Does that make sense? I didn't realize they weren't doing it as a group. So they actually don't want any more than individual cans and individual packages. So add that in there. If it'll let me add it in there, that'll be great. They want it to look like that because they actually don't want the individual packages. And sometimes they'll explain in it, it's a space thing, or like with this was a cost thing. So when you look at your constraints, sometimes they'll tell you, the floor space will only allow this many for this and this many for that. And so, or a parking lot, they can only park this many vehicles based on size or this many buses based on size. All right? The other constraints are understood, okay? You only see a first quadrant here. So you have understood constraints. The understood constraints here is that you're not going to have a negative amount of mixed nuts and you're not going to have a negative amount of roasted peanuts. Those are understood. Okay, so even though they don't tell you that, that's a logical constraint on this particular problem. All right? So we have our constraints, we have our profit. We're gonna graph our constraints, we're gonna maximize our profit. All right, so this is where putting it in slope-intercept form is not logical, all right? Because slope-intercept form is going to have a really big intercept and then a teeny slope that you're gonna try to walk through. So for most of these, it's better to do it in intercepts, your X and your Y intercepts. So if I'm doing this particular one, I want to do my intercepts. I'm going to say, well, for the first one, I will set my Y equal to 0 and solve for my X intercept. And what do I get there when I solve for that? So X is 25. All right, same thing when we do Y. Make your X 0 and set your Y equal to it. What happens there? No, that one's 25, by the way, right? This one's 25. That one's not 25. We did Y. What's this one? What's this guy? Yeah, you should get a decimal there. 41 and 2/3. Okay, that's a beautiful thing to graph, by the way. Yeah, that's 2/3. All right, what about the next one? We're gonna look at these intercepts. Make my y 0. Set it equal. What happens when we do 600 divided by 24? That one's 25, right? And then 600 divided by 15. All right. So when you do these, intercepts are the easiest way to do these word problems, because I promise with the word problems, you're very likely going to have this crazy slope going on. All right, so now we're going to graph it. These are going to be tens, so 41 and 2/3 down here. And then my y-intercept was 25, so that guy's going to be there. And I'm going to wait to graph this, wait to shade it at the end, just so I don't have it all over the place. All right, what about my next one? I'm going to have an x-intercept of 25, a y-intercept of 40. And then, of course, my constraints are my first quadrant. So the only one you really have to worry about is where they intersect. And I'm going to show you that in a second. All right, so I have 4 vertices, right? This is a quadrilateral. I have a vertex here. Do I even need to test that 0, 0? Is that going to be my highest profit? Hopefully not. We have a problem if it is. All right, this is an intercept. So this intercept is going to be 25, 0. That's easy. I have this intercept, right? That's going to be 0, 25. Okay? And so then in this shaded region here, I have where they cross. Now, when you graph, that's not the easiest thing to see, okay? It's not easiest to see where they cross there. However, I have a method for solving that I can do here to figure out exactly where they intersect. We did it for our bell work, the very first one on our bell work. I can use elimination here, right? And so that's what you're going to do. You're going to use elimination to figure out where they cross. And this is an easy elimination. They were nice to us, right? I can multiply the top by -2, and I'm going to get an easy elimination. So I have -24x minus 40y equals -1,000, right? And then for the bottom, I have 24x plus 15y equals 600. Those cancel. What's 40 minus 15? -25 there. 1,000 and 600 give me -400. What's 400 divided by 25? 16. All right. And if I have my 16, how do I find my other one? Yeah, just plug it in, and you should get 15, by the way. All right. So that's how you're going to figure out if you have a graph that's big like this. Now, if they give you one with small numbers and you can see that they intersect at a perfect place, you're good to go. If you get numbers that do this, you're going to want to use one of your other methods of solving to get it. When you plug these in, 25, 0 gives you 450. 0, 25 gives you 375. 15, 16 gives you 510. Where's your maximum? And what is your maximum? So then in a word problem, you're going to have to tell me that a little more specifically. In a word problem, you are going to have to say 15 cans of mixed, 16 of peanuts gives me a profit of $510. You need to define what you've just given me, okay? Does that make sense? So you have to tell me what you have and how much your profit is. What you have and how much your profit is.